In this video, we're going to have a look at combined questions on the total surface area and volume of three-dimensional shapes. The first example is about the ratios between the total surface area and volume of different shapes. The measurements of a cube with side lengths of 5 centimeters are doubled to form a new, bigger cube. Question A. Calculate the total surface area of the original cube. To calculate the total surface area of the shape, you need to know that there are 6 identical squares. Each square has side lengths 5 by 5, which gives an area of 5 squared. So the total surface area is 150 centimeters squared. Question B. Calculate the total surface area of the new, bigger cube. The information stated that to form the new cube, the original cube's measurements were doubled, which means that all the sides will now be 10 centimeters. So, to calculate the new total surface area, it will be 6 sides of 10 by 10. This will give a new total surface area of 600 centimeters squared. Question C. Determine the ratio of the total surface area of the small cube to that of the big cube. We've already calculated both these values, so we can just substitute. This will be 150 over 600, and once you simplify that, it will be a ratio of 1 over 4, which means that the surface area of the big cube is 4 times that of the original cube. Question D. Determine the ratio of the volume of the small cube to that of the big cube. So now we first need to determine these volumes. The volume of the small cube is the area of the square, and the square is a 5 by 5 square, multiplied by the distance to the next square, or the height of the prism, which is also 5. And the same goes for the bigger cube. Here, the length and breadth will be 10, and that is multiplied by the height, which is also 10. You could have also written this as 5 cubed over 10 cubed. This is a ratio of 1 over 8, which means that the volume of the bigger cube is 8 times that of the small cube. The reason for this is that each measurement was doubled or multiplied by 2. So, in the end, we enlarged the cube by 2 to the power of 3, which gives us the 8 times bigger. Example 2. The sketch shows a barn with all the measurements given. Question A. Determine the amount of steel that is needed to build the whole barn from steel with only the floor and window excluded. To answer this question, we need to determine the total surface area of the whole shape. I'm going to start off with the area of the rectangular prism. So here we have 2 rectangles, front and back, of 3 by 5 meters, and 2 left and right of 3 by 8 meters. The bottom rectangle, which is the floor, is excluded, and the top rectangle as well, because a roof will still be added. This means we will have 2 rectangles of 3 by 5 meters and another 2 rectangles of 3 by 8 meters. Now we need to remember that the window is excluded. Therefore, we need to subtract this rectangle, and that will be 1 rectangle of 2 by 1 meters. Now we can move to the triangular prism, which forms the roof. Here we have 2 triangles, one at the front and one at the back. This means we will add 2 areas of a triangle. And for these triangles, the base will be 5 meters and the perpendicular height 2 meters. And finally, we have 2 rectangles that form the last part of our roof. And these 2 rectangles, front and back, are identical. So we'll add 2 rectangles of 3,2 by 8 meters. So the total amount of steel needed to build this barn is 137,2 square meters. Question B. Calculate the volume of the barn. For this, we will have to add up the volume of a rectangular prism and a triangular prism. For the rectangular prism, I'm going to take the pink rectangle in front as my base, and that is a 3 by 5 rectangle that has been stretched for 8 meters to form the volume. For the triangular prism, the base is the green triangle in front, and the area of that triangle is a half times by the base of 5 and its height of 2, and this has been lengthened for 8 meters as well to form the volume. So the volume of the whole barn is 160 meters cubed. Question C. Determine the capacity of the barn in liters. 1 cubic meter is 1 kiloliter. So we know that this barn can hold 160 kiloliters. If we need to convert this to liters, you need to still multiply it by 1,000. So this is 160,000 liters.